Hello everyone. In today's session we are going to discuss about switches. Types of switches, difference between layer 2 and layer 3 switch. Also we'll see how switches forward frames and populates the MAC address table. And at the end I will list some of the commonly used Cisco switch models. Switches are key building blocks for any network. It has multiple ports and it connects multiple devices such as computers, laptops, wireless access points, printers, CCTV cameras, and servers on the same LAN within a building or a campus. A switch enables connected devices to share information and talk to each other. It is called layer 2 device because it works on the layer 2 of the OSI model and it uses MAC address in order to share data from one end to the other end. It learns the physical address of the device that are connected to it and store the physical address called MAC address in its MAC table or CAM table. Unlike hub, switch is an intelligent device. Switches are ASIC based. ASIC stands for Application Specific Integrated Circuit. This feature helps the switch to make the switching decisions very quickly. Every port on a switch is in a different collision domain. That is, a switch is a collision domain separator. All the ports on a switch are by default in the same broadcast domain. A broadcast domain contains all the devices can reach each other at the data link layer, that is OSI layer 2 by using broadcast. There are two types of switches, unmanaged switch and a managed switch. An unmanaged switch is designed so that you can simply plug them in and they work without any configuration required. Unmanaged switches are typically for basic connectivity. You'll often see them used in home or wherever a few ports are needed. One of the example of unmanaged switch includes Cisco 100 series switch. Managed switches can be configured to custom fit your network. Managed switches give you greater security and more feature. With a greater control and flexibility, you can better protect your network and improve the quality of service for those who access the network. One of the examples of managed switches in the data center are Cisco Nexus 7K series switches. Managed switches are further divided into two types, layer 2 and layer 3. A layer 2 switch works with MAC address only and does not care about the IP address. Layer 2 switches basically do switching only, which means they operate using devices MAC address to redirect the data packets from the source port to the destination port. For the inter-VLAN communication on a layer 2 switch, an external layer 3 router will be required for the devices to communicate. A layer 3 switch or a multi-layer switch can do all the job that a layer 2 switch does. Additionally, it can do static routing and dynamic routing. That means a layer 3 switch has both MAC address table and an IP routing table. And it handles intra-VLAN communication and packet routing between different VLANs as well. How switches forward frame and dynamically populates a switch MAC address table. Let's take an example of small network with a PC and a laptop connected to a switch. When you first boot up the switch, it has something known as CAM table or MAC address table. A MAC address table is essentially empty and it is going to include our MAC address that is going to learn from the end devices on our network. Let's say the PC has the MAC address with a couple of zeros and 1 and the laptop has a MAC address of a couple of zeros and 2. Let's say if you want to ping from PC A to PC B IP address, the IP address of PC A is 1.1.1.1 and PC B is 1.1.1.2. Next, to communicate with the PC B, the PC A sends an ARP message. ARP in a nutshell is a communication protocol used to resolve the layer 2 address associated with the layer 3 address, that is the IP address. The PCA sends a frame and the switch receives a frame from PCA on FA0/1. The switch examines the source MAC address and compares it to the MAC address table. If the MAC address is not available in the MAC table, it associates the source MAC address of PCA with the ingress port FA0/1 in MAC address table. After the switch has recorded the source address information, the switch examines the destination MAC address. If the destination MAC is not available in the MAC table, the switch floods the frame to all the ports, except the ingress port. Then the destination device PCB replies to the frame with a unicast frame address to PCA. The switch enters the source MAC address of PCB and the port number of the ingress port in the address table. The destination address of the frame and its associated ingress port is found in the MAC address table now. The switch can now forward the frame between the source and the destination devices without flooding because it has entries in the table that identify the associated ports. Cisco offers some exciting model of switches that can be used depending on the requirement and the network you have. Cisco Catalyst 3650 series switches can be used as a LAN access switches. Cisco Catalyst 1000 series switches can be used as LAN compact switches. Cisco Catalyst 9600 series switches can be used as LAN core and distribution switches. At the last, Cisco 9K series switches are the next generation data center switches. With this, I would like to say switches create a network, routers connect the network. That's it for today. Thank you for watching. Please like and subscribe and hit the bell icon. Thank you for watching.